All right, guys. So we are going to keep going in our notes. All right, so let's go ahead and go down here. Excuse me. Down here where it says fill in all the numbered angles with appropriate angle measures. So what we want to take a look at when we're looking at this question is first we want to take a look at what shape are we looking at the properties of. So we're looking at a rectangle, and this tells us the measure of angle 1 is 70 degrees. So I'm going to go ahead, go to angle 1, and I'm going to write 70 degrees if my computer doesn't keep jumping around everywhere. So 70 degrees. Well, what do I know about a rectangle and its angle measures? If you look back at when we talked about the definitions, we know that a rectangle has 4 right angles. So I can know the measure of angle 2, because if the measure of angle 1 is 70, the measure of angle 2 would have to be 20 degrees in order for that corner to be 90 degrees. Well, what else do I know about a rectangle? Well, I know a rectangle is a parallelogram. So I can also add on here that I know the opposite sides are parallel. Well, what does that tell me? How does that help me in figuring out the rest of these angles? Well, if we remember, if I have parallel lines and a transversal that cuts between them, I would know that the measure of angle 1 is congruent to the measure of angle 5 by alternate interior angles theorem. So I know that the measure of angle 5 is 70 degrees. And the same way for the measure of angle 2 would have to be congruent to the measure of angle 6 by the alternate interior angles theorem using the top and the bottom set of parallel lines. Okay, so now I have a couple different angles, but I still don't have everything that I need. So right now might be a good time to kind of flip back and take a look at those properties that we know about parallelograms. Okay, so, rectangles and parallelograms. So I know in a parallelogram that opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. And then to add into that, with a rectangle, we know the diagonals are congruent. Well, one of those properties can really help me in this case. And the one I'm talking about is actually going to be for a parallelogram, knowing that the diagonals bisect each other and knowing that the diagonals are congruent. So what that tells me is that each of these pieces of the rectangle are going to be congruent, because I know that all of the diagonals are bisected, they're split in half. And if my diagonals are congruent, that means they're split evenly in half. So what I'm looking at now is I have four triangles. And they're all isosceles triangles. So if we remember our isosceles triangle theorem, that states that our base angles are going to be congruent. That lets me know that with the measure of angle 1, that's going to be congruent to the measure of angle 8, because those are base angles of an isosceles triangle. So measure of angle 8 is 70 degrees. Same thing with the measure of angle 4 and the measure of angle 5. Those are base angles. And so those are both also going to be 70 degrees, since we already knew angle 5. And we can keep going with that. The measure of angle 7 is going to be 20 degrees. The measure of angle 3 is going to be 20 degrees. So now all we have left is figuring out angles 9, 10, 11, and 12. Well, now if I look at each of my triangles individually, I can see that I have two different triangles, one that has base angles with 20 degrees and one that has base angles with 70 degrees. So I can use that third angles theorem and figure out what that third angle is going to be. Oh, okay. So for my two side triangles, I can say 70 degrees plus 70 degrees plus something equals 180 degrees. So I would say, okay, 140 degrees plus something equals 180 degrees. So my third angle, so angle 9 and angle 11, would have to be 40 degrees. And I can do the same thing with my other two. I could say I have 20 degrees plus something equals 180 degrees. So 40 degrees plus something equals 180. So that something would have to be 140 degrees. So angle 10 and angle 12 would have to be 140 degrees. Awesome, so we're done with that first shape. So let's take a look at the next one, a rhombus. So in a rhombus, we know a couple of things. We know that the sides are all congruent, and we know the opposite sides are parallel. So let's go ahead and put that in here just so that we can see it a little bit more clearly. We know opposite sides are parallel, and we know that all four sides are congruent. Awesome. So if I know that the measure of angle 1 is 40 degrees, okay, so then what else do I know? Well, again, I could look at my alternate interior angles theorem and see that the measure of angle 5 would also have to be 40 degrees. Awesome. What else do I know about a rhombus? Well, I know that my diagonals are perpendicular. So that tells me that all of the angles formed by my diagonal are going to have to be 90 degrees. Well, that makes it really nice because now the two triangles that I have on the sides here, let me go ahead and just outline those. We have two angles on these two triangles. So what I can do is I can say, okay, well, 90 plus 40 plus something equals 180 degrees, or 130 plus something equals 180 degrees? Well, that something would have to be 50. So I now know that the measure of angle 4 is 50 degrees and the measure of angle 8 is 50 degrees. Okay, but that still leaves me with quite a few angles, 4 angles, that I don't know the measures of right now. But I can know them. So let's take a look back at those rhombus properties. So we know that 4 sides are congruent. We know the diagonals are perpendicular. The last property we talked about were that the diagonals bisect both pairs of opposite angles. So I can know that if angle 1 is 40 degrees, angle 2 is 40 degrees. Angle 4 is 50 degrees. Angle 3 is 50 degrees. Angle 5 is 40 degrees. Angle 6 is 40 degrees. And if angle 8 is 50 degrees, angle 7 is 50 degrees. And there we go. We found all of those angle measures. All right. We have 2 more that we'll run through really quick. A square. So a square is nice because we know that it has all of these properties. We know that opposite angles are bisected. We know that the diagonals are perpendicular. And we know that we have 4 pairs of right angles. So I can actually know that all of my outside angles are 45 degrees because since it's a rectangle, I have 4 right angles. So all of these are going to have to be right angles. And since I am a rhombus, my opposite angles are bisected. So they're split in half. So all of my outside angles, 1, 2, 3, 4, 5, 6, 7, and 8 are all going to be 45 degrees. The other thing that a rhombus tells me is that, if I don't jump away, is that my diagonals are perpendicular. So I know that 9, 10, 11, and 12, those are all going to be 90-degree angles. Awesome. All right. So the very last one that we're going to look at is a kite. So in this kite, we know that the measure of angle XUV is 84 degrees. So let's go ahead and label that. So XUV, that one is going to be 84 degrees. And WVX, this is going to be 68 degrees. And we're trying to find the measure of angle VWX. So we're trying to find, hello, get out of here. Okay, we're trying to find this angle here, and I'm going to mark it with 3 tick marks. We're trying to figure out what is that going to be. So this one, we can actually just take a look and see. Well, I know, and I could see here, I have an isosceles triangle that's created right here with my kite. Since those two sides are side VW and side XW, those are congruent sides, I can actually tell that this is an isosceles triangle. Well, if you guys remember from earlier, we've already used it today. We have that isosceles triangle theorem that tells us that those base angles are going to be congruent. So if we have WVX is 68 degrees, I also know that VXW is going to be 68 degrees. And then I can use my third angles theorem, and I could say 68 plus 68 plus something equals 180 degrees. So 68 plus 68 is going to give me 136 plus something equals 180. And when I solve for this, I'm going to find that that third angle would have to be 44 degrees. So my missing angle is 44 degrees. All right.